Welcome to video 4 on the arithmetic sequence. In an arithmetic sequence, each term has a common difference with the term preceding it. Now, some people pronounce this arithmetic. I pronounce it arithmetic. It's really the same thing if you hear a different pronunciation of it. But it's a sequence. It's a sequence of numbers. But an arithmetic sequence has a common difference. And basically, what that means is to get from one number to the next number, we add or subtract a number. And then we add or subtract that same amount to get to the next one, and so on, and so on, and so on. Now, we would say that this is the first term in the sequence, and this is the second term, and third term, and so on. We have a symbol for that. We say A with a subscript of 1, A with a subscript of 2, A with a subscript of 3, and that is just a symbol we use to represent first term, second term, third term. So 11 would be A4, and 16 would be A5, and like if we were to see A10, that means the 10th term in the sequence, and so on. So that's just an important symbol that we use to represent the terms in the sequence. Now, a big part of this is recognizing what the common difference is. Now, the common difference is the number we add or subtract to get from one term to the next. So how do I go from -4 to 1? How do I go from 1 to 6, 6 to 11, 11 to 16? And we use the letter D as the variable. I mean, it's not really a variable because it's a constant, but it's the letter we use to represent the common difference, D for difference. And so in this case, D would be 5. We're positive 5. We add 5 to -4 to get to 1. We add 5 to get to 6. We add 5 to get to 11. We add 5 to go from 11 to 16. So we're adding 5 each time to get to the next term, and that's what that is. Now, sometimes you can just look at a sequence and see it, but you could always subtract any two consecutive terms. Like if I were to do A3 minus A2, and that's meaning the third and the second term. So A3, our third term, 6, minus our second term, 1, equals 5. And that's the same thing if I were to do, 16 minus 11 is 5, 11 minus 6 is 5, 6 minus 1, 1 minus -4 is also 5. So you take any two consecutive terms and subtract them, you'll find that common difference. So that's pretty easy. So for these, just find the common difference. So we're going to take any two terms. I'll take 9 and 12, and you can just subtract them. 12 minus 9 equals 3. And so the common difference here is 3. And you can verify it by looking at another one. 18 minus 15 is 3. 9 minus 6 is 3. 6 minus 3 is 3. How about in this next one? If I take my first two terms here, 3 minus 5 equals -2. And so my D, my common difference, is -2. So instead of adding 3 like in this first set to get to the next term, I'm minusing 2 to get to the next one in this set. And we see that. 5 minus 2 is 3, minus 2 is 1, minus 2 is -1, minus 2 is -3, and so on, so on, so on. So find the next three terms of each sequence. Well, first thing we want to do is figure out what is D. For this one, how do I go from 1 to 5? Well, I could do 5 minus 1, but I think you could probably just tell that D equals 4. So now continue the pattern. We're positive 4, so we're adding 4 each time. So 17 plus 4, 21. Plus 4, 25. Plus 4, 29. In this next one, how do I go from 2 to -1? Well, if I'm not sure, I could just do -1 minus 2, which is -3. And you could always tell when it's negative when I see my sequence is going down as opposed to when it's going up. It's going to be positive. And so I'm minusing 3 each time to get to the next term. So minus 3 from -7, I get -10, then -13, and -16. This is a formula that we have to find the nth term of a sequence. Like if I want to know what is the 17th term of a sequence, that would be A17. Well, to find the 17th term in the sequence, A17, what I need is A1. So you have to know the first term in the sequence in order to use this formula. So whatever my first term is, I'm going to add it to two things being multiplied. The two things being multiplied are n minus 1. Now, n minus 1 is what term you want. So that would be 17 minus 1. So I'd end up with 16 times whatever the common difference is that we've been talking about. So if you want your 17th term, minus 1 to get 16 times your common difference, plus your first term. So let's look at a couple examples on how to use this formula. So find the seventh term of this arithmetic sequence. Now, this is not a very complicated sequence, and the seventh term isn't too far away, so we could just continue the pattern like we did earlier. First step is finding D. D here, how do I go from 2 to 7? D is positive 5, and I could do 7 minus 2 to get that. So I could just continue this pattern. Let's see, I add 5 and I'll get 17, and add 5, I'll get 22, and add 5, I'll get 27, and add 5, I'll get 32. And so this is my first, second, third, fourth, fifth, sixth, and seventh term. So A7 equals 32. And you can do that. That's acceptable as long as you list them all out. But let's try it with the formula. The formula says that if we want A7, what we need is we need the first term. Now, the first term in our sequence is the first term shown here would be 2. So that's 2 plus the product of two things. The product of D, which we figured out was 5. How are we getting from one term to the next? And n minus 1, and that comes from, this is our value of n7. So that would be 7 minus 1 is 6. Okay, that's 7 minus 1 is how we're getting this 6 here. And so that would be 2 plus 6 times 5 is 30. 2 plus 30 is 32. And that's what we got up here. But why don't we, didn't it seem easier just to continue the pattern here? Well, it was in this case, I think. But in this next example, when I say what's the 50th term, we'd have to list out all 50 terms. And there's a good chance we might make a mistake, but that would take a while. Or if I said, what's the 250th term? It would take a very long time. So that's where the formula is really valuable here. So we want the 50th term. So that would be A50. And what we really need to start off with is the first term, and that's 12. And that's going to be plus the product of two things. First is our n minus 1. Our n minus 1 in this case is, we want the 50th term, so it's 1 less than that, so it'll be 49. Not the 49th term, just the number 49. And sometimes that's confusing. That's a mistake students make, is they put the 49th term in there. We don't need the 49th term to get the 50th term. We need our first term. Our first term is 12, but then it's n minus 1, 50 minus 1, 49 here. And D, we need D. How am I getting from one term to the next? How am I getting from 12 to 15? Well, 15 minus 12 is 3, so times 3. Okay, let me just get my calculator up and running to help me with the algebra a little bit here. But again, an important thing that I mentioned earlier that you want to remember on this formula, and one thing that's definitely worth pointing out, is this formula is not given to us on any reference sheet. It's a formula we're expected to memorize, and so you do need to know it, like the quadratic formula. It's one of those things you have to know. But like I was saying before, an important mistake people make a lot of times is they will substitute. They think this isn't 49. They do the 49th term. But make sure you do a 49 there, n minus 1. If you want the 50th term, you put a 49 here. If you want the 10th term, you put a 9. If you want the 7th term, you put a 6. What term you want minus 1. In your first term, we're going to get from our sequence, and then D you got to usually figure out. So my calculator is ready. 49 times 3 is 147. So let me get back to this. And so we have 12 plus 147 is going to be 169. All right, one more problem I'd like to do, and I just want to do this one because instead of listing a sequence, I'm actually giving you A1 and D. So it should be a little bit easier than this because we didn't have to do a lot of work to figure out A1 was 12. We could just see it there. But we did have to figure out D. So this is just kind of a different way of representing it, but it's actually shorter because I'm giving you the two pieces you need here. So we want the 16th term, so that's A16. And we want the first term, which you're being told is 5 up here, plus the product of n minus 1 is your 16 minus 1 is 15, and D, problem's telling us, is negative 4. And so we get this together. It's going to be 5 plus 15 times negative 4 is negative 60. Plus 5 is negative 55. And that's it for arithmetic sequences. In the next video, we're going to talk about geometric sequences. And the difference there is that instead of having, plus 3, plus 3, plus 3 to get to the next term, it's going to be times 3, times 3, times 3, using multiplication and division instead of addition and subtraction to go from our sequence of terms. We'll talk about that in the next one. See ya. See ya.